Hello everyone, my name is Bismarck Yeboah, a master's student in the Civil and Environmental Engineering Department at the University of Vermont. I work with Anna Cassavant, a student research colleague, and we work under Professor Driver Houston and Professor Manda Diwalker. Today, I'm here to present on our research, which focuses on analyzing the effects of ground glass pozzolan as a supplementary low-carbon cementitious material in concrete. What's the motivation of this research? In recent times, global warming has become one of the major challenges the world is facing, causing severe storms and floods, climate change, destruction of the ecosystem, drought, diseases, and a lot more terrible effects. The root cause of global warming is the emission of CO2 into our environment. There are several sources of CO2 emissions, and one of them is cement production and transportation. Cement is a construction material that is used worldwide, and it is one of the main components of concrete. To achieve high-performance concrete in terms of strength and durability, high binder or cement content is often used. However, about 5% to 7% of the world's CO2 emissions are associated with cement production and transportation. Also, higher binder content results in higher cost, concrete cracking, and shrinkage damages. Supplementing binder content with supplementary low-carbon cementitious material will result in the reduction of CO2 emissions, relatively lower cost, reduction in concrete cracking, and shrinkages, thereby reducing or contributing to the sustainability of our environment. The objective of this research is to develop a concrete mix design or concrete mix designs that meet modern high-performance durability standards while supplementing cement with ground glass pozzolan, a more environmentally friendly concrete material. The research will also explore mix designs with locally sourced materials whilst investigating the effect of packing density in optimizing binder and aggregate compositions. So in figure 1 on the left, it shows ground glass pozzolan as a supplementary low-carbon cementitious material, as we have here. And this material comes from recycled waste glass, grinded to the fineness of cement. The figure in the middle shows poorly packed aggregates, which require relatively higher volume of binder paste to fill all these pore spaces, as compared to the figure on the right, which has maximum packing density and will require relatively lower binder paste to fill the void spaces. Now let's move on to some preliminary results. Figure 2 shows compressive strength test, electrical resistivity and chloride penetration test, and concrete shrinkage test from preliminary works performed so far. And the results from these tests can be seen in the graphs below. Figure 3 shows the results from electrical resistance measure of chloride penetration for specimens containing 0%, 12.5%, 25%, and 37.5% ground glass pozzolan. The original resistivity of the specimens before soaking were all below 4,000 ohms, and the resistivity reduced to less than 1,000 ohms the first day the specimens were soaked. And on the 7th day after soaking, it can be seen here that the specimen containing 37.5 ground glass pozzolan attained the highest electrical resistivity of about 13,000 ohms, followed by the specimen containing 25% ground glass pozzolan. Figure 4 shows the results from compressive strength test of specimens containing 0%, 12.5%, 25%, and 37.5% ground glass pozzolan after 20 freestyle cycles. The specimen containing 0% ground glass pozzolan attained the highest compressive strength of about 5,000 psi, followed by the specimen containing 12.5% ground glass pozzolan. And it can be seen here that the greater the quantity of ground glass pozzolan, the more the compressive strength is reduced. But these values are all above 3,000 psi, which is acceptable. Also, figure 5, it shows the concrete shrinkage test of two concrete specimens, one containing 100% ordinary Portland cement and the other containing 25% ground glass pozzolan. So the specimen containing 25% ground glass pozzolan has relatively lower shrinkage than the specimen containing 100% ground glass pozzolan, as can be seen here compared to this. Yes, so these are our upcoming works. The research seeks to optimize binder and aggregate composition by packing density, and it will also develop concrete mix design by partially replacing cement with ground glass pozzolan and other supplementary low-carbon cementitious material, such as nano-silica and Portland limestone cement. The maximum packing density of aggregate will be determined to reduce the void spaces of the aggregate, hence reducing the binder paste required to fill the spaces. The research will also explore mixed designs with locally sourced materials or aggregates, which has the benefit of reducing carbon emissions from aggregate transportation. Testing techniques will also be employed in this research, and some of these are the freestyle, the compressive strength, shrinkage, electrical resistivity, and chloride penetration tests. And we hope this research helps to reduce the billion tons of CO2 emitted annually into our environment and help our environment to be more sustainable. This concludes my presentation. Thank you for listening, and if you have any questions, kindly contact my supervisor on driver.houston@uvm.edu or manda@uvm.edu. Thank you very much.